So good afternoon, everybody. I'm happy to be here today. I'm going to be talking about a topic that we've been developing for the last few years here with a group in TTI. And as you can see in your programs, it's labeled Use of Rejuvenators with Recycled Materials. I'm going to be using the term recycling agents in the presentation. Usually rejuvenators and recycling agents are used interchangeably. So I just wanted to make that clarification. The reason for this topic to be timely is because a lot of agencies are pushing to increase the amount of reclaimed asphalt pavement, or RAP, and recycled asphalt shingles, or RAS, in mixtures. And all that is good because it helps in the economic sense, like the contractors save money because they don't need to use the virgin materials or as much as the virgin binder. And also because of environmental reasons, as you don't need to be mining a lot of those raw materials and savings in that regard. However, there's still some concerns with regard to using high amounts of recycled asphalt pavements or shingles in mixtures, because sometimes there are problems during construction in terms of workability and compaction. And also because in general there's a concern that these mixtures using aged materials will be more prone to cracking or other issues such as raveling. So I want to kind of start with the poll everywhere if you want, and grab your phones or your tablets to go online. And we conducted a survey a few years ago, 2 or 3 years ago. So this is sent to all DOTs. We got about maybe 45 of the 50 states responding. So what do you think when we asked them, what is a typical RAP content you use in your surface asphalt mixtures? What do you think the response was? So the options are less than 20%, 20 to 30%, or more than 30%. So I'll give you half a minute or so you can submit your responses. Again, this is nationwide, not just Texas. Okay, so it looks like about 57% of you said, or more, 63% said less than 20%, and that is correct. A lot of the DOTs are using about 15% at most on their mixtures. So what about for RAS? What do you think the state DOT said? What is the typical RAS content used in surface asphalt mixtures? Is it none? They don't use any, or up to 3%? Or more than 3%. So you can answer A, B, or C on your phones or tablets. Okay, it seems that most of you think up to 3%, but according to their responses, actually it's none. Most DOTs are not allowing the use of RAS in their mixtures. Okay, last question for you, based on this survey again of all DOTs. What are the most common barriers to using more RAP and RAS in surface asphalt mixtures? What do you think they said? Is it because of specification limits? Is it because of the availability of the recycled material? Or is it because of the quality of the recycled material? Seems that most of you think is the quality, but based on the responses, it's actually their specification that limits them to use RAS. There's usually materials available, and as far as their answers were, they were not concerned about quality, but their specifications would limit the use of the RAS. So before we keep talking about recycling agents, let's just review a little bit of how we express RAP and RAS content. So if you think traditionally, it is expressed by terms of the percent in the total mix. So for example, we say 10% RAP, 5% RAS. So people sort of tend to use this terminology. However, recently, there's been something that has been introduced, a new term called the recycle binder ratio, or RBR. And opposite to the traditional way of expressing the amount is done in a decimal fashion. So If you look at this equation here, you have your RAP component, the RAP-BR, your RAS component, the RAS-BR, and the way that is calculated is just taking the percent of binder in the RAP times the binder content. So this is your numerator, like how much RAP you're going to put in there, how much binder the RAP has, divided by the total binder content. And the same way for the RAS. I just put there a link. That's like a link to an NCAT newsletter that has a very good sort of explanation about this new term and some examples if you want to look at it later. It turns out that if you look at text specifications, this table is in items 340, 341, 344. You're actually also using recycled binder ratio. So in this table, you have your original specified binder. You also have the allowable substitute PG binder, which you will note has a lower, either high or low PG grade. And you also have different limits for surface mixtures, intermediate mixtures, or base mixtures. The little bit confusing part, at least from my point of view, is that you're still expressing these numbers in percentage instead of the decimal as is done by other institutions. So somebody can look at this and still think, oh, this is 20% RAP, which if you're only using RAP may be okay or close. But if you look at here at the bottom of the table, this is the combined recycled binder from RAP and RAS. So if you're using both materials, then you can't think of these straightly as a percentage. So what are the advantages of kind of moving away from the percentages to the RBR? Well, for one thing is that you're separating the RAP and the RAS, which is beneficial to do. And you're sort of doing a weighted average of those two components. One of the downsides is that it sort of assumes 100% blending. And I will talk more about this blending issue later, and you will see how and why that is important. So this is just on the right side of your screen. You'll see a proposed notation, and this is by NCAT. It has not been used as far as I know or seen from any DOT, but what they're proposing is that you sort of use both the percentage and the RBR together. So you will have like an A, B, and D and E value, which will show the percentage and the RBR. It's something they're proposing. It may be useful, so it clarifies the issue. So going back to the topic of recycling agents is like we said that we're beneficial. Not a lot of agencies are using high quantities, so how can we incorporate more RAP and RAS in surface mixtures? Well, as I showed in a previous table from the text specifications, you can lower your binder PG. That's a way to do it. Other agencies lower the air void content. So instead of having, 4 or 5%, they go to 2 or 3, so they increase the amount of virgin binder. Another way to do it is by adding these recycling agents. So you have your RAP, your RAS, your virgin binder, the virgin aggregates, and then you will add this extra component to the mixture to be able to introduce more of those materials. So what are recycling agents? Well, these are just chemical products. Think of it as just kind of like a warm mix additive. It's sort of, in a general sense, just another additive you can put in your mix. So what do they do in the mixture? They reduce the mixture stiffness. So that asphaltene to maltene ratio, like kind of the stiff part to the volatile part, they sort of try to put that into balance again. And they improve the low temperature and high temperature PG. All that translates into what it's important to achieve, which is a better cracking resistance. As I mentioned, these materials are heavily aged, so they will tend to crack easier. And some of the suppliers claim there's other benefits, such as improved workability and compaction. What types of recycling agents are available? I took this table from the Asphalt Pavement magazine. It was published back in 2015. This was published by NCAT. So there they have 5 categories of recycling agents, from paraffinic oils, aromatic extracts, etc. However, even though it has been just a couple of years, this was published in 2015, we think there's a lot more products out in the market now to where this table is a little bit outdated. Right now, there's a lot of bio oils out in the market, and there's modified, reacted, stabilized vegetable oils that sort of don't fit neatly into any of these categories. So the next logical question is, how do I select a recycling agent? And this is sort of like the million-dollar question, because there's no easy answer yet to how to select a recycling agent. Here at TTI, we have done some research. We have done some characterization of different recycling agents, both chemically and rheologically. So those are the charts I'm showing there. On the left, you can see we measure what is called FTIR, which is just the carbonyl area, how the material is changing with aging. So we took several types of recycling agents here. T are tall oils, A aromatic extracts, vegetable oils, bio-based oils, and we just did like RTFO aging, 20 hours in the PAV, 40 hours in the PAV. So for each one, you will see those bars changing. This is the carbonyl area. So you see, for example, for this T1, there's a huge change when you age the recycling agent. This is just the recycling agent itself. Now look, for example, at this V, this vegetable oil, has almost no change whatsoever. Now what about when you look at rheology? Well, there seems to be a correspondence. This is using the 50 millimeter plate, the bigger plate in the DSR. That's what's used to characterize these materials. So we're getting the viscosity. And also we're testing them in their original state after RTFO, 20 hours in the PAV, 40 hours in the PAV. So you can tell how there's a correspondence. If the FTIR carbonyl area change a lot, it will also change a lot in the rheology. But if it's very stable and chemically, it's also relatively stable rheologically, that there's not much change. So we think this is preliminary work, but we think this is sort of tools that we can look into to give the DOT some way of selecting or be able to discriminate. If you have 2 or 3 recycling agents, how can I choose the best one? As I said, this is work in progress, so keep tuned. We'll have more results later. The next logical question is like, okay, now I know which type of recycling agent I want, is how much do I add to a mixture? And this is also an important question, because usually the current practice right now is DOTs just go by what the suppliers recommend, or they do limited binder testing. So far we have used the binder tools like the SuperPave, the DSR, to do high temperature PG grading, and the BBR to do low temperature PG grading. So just as traditionally done for binders, we do ONH and RTFO-H in the DSR and 20-hour PABH in the BBR. From the BBR results, we can get something that's called the delta TC, it's just shown there at the bottom. It's just a simple calculation, the temperature at which the binder or blend meets the criteria for the S and M value. We just subtract those two. So we have developed a method for this recycling dosage selection. I'm going to show you 2 ways of doing this. I'm calling this the detailed method because it involves more testing. And then I'll show you a quick method. It's like, how can you estimate this dosage without doing all the binder testing? So for this detailed method, you will need to prepare blends. And what I'm calling a blend is that you will need to take your virgin binder, you will need to extract and recover the binder from the RAP or RAS, and then you will need to blend that with the recycling agent. So you will have a blend that has no recycling agent, and then you'll have 2 other blends, one with a low dosage, say 2 or 5%, and then another one with a high dosage, say 10%. And then you will plot the results. So here I'm showing a graph. We have the high temperature PG grade on the y-axis and the dosage of the recycling agent. In this particular example, we're doing 0%, like no recycling agent, and then 2% and 10%. And we're showing 2 lines, one for the original blend and then one after RTFO. On this particular example is a 0.3 RBR blend with a PG6422 virgin binder, 0.1 RBR of Texas wrap, 0.2 RBR of the manufacturer waste alpha shingles, and the type of recycling agent, which is a toil oil. So after doing that, in the same graph, we put the low temperature PG grade here on the secondary y-axis, which is these 2 bottom lines. So one is just the M control and one is the S control. And from there, we know what are the requirements of the climate where this project or payment is going to go in. So say, for example, my target grade is a 70-22. This is based on climate and traffic. So from that, I can estimate on the high end how much dosage would I need to get to 70 on this red line. So that gives me about 6% recycling agent dosage. From there, I check the low temperature grade just to make sure I'm okay. And in this particular example, it is fine. So it gives me a blend grade of 70 minus 23 with a 6% recycling agent. So as you can tell, here we still need to prepare blends, do testing, low and high temperature PG grading. So is there a way we can sort of circumvent some of these testing and have a quick estimate instead of doing all that work in the lab? So this is what I'm calling the quick method for estimating the recycling agent dosage. In this particular case, you will only need the virgin binder and the extracted and recovered recycled binder. You will not need to make any blends, and you will only need to test on high temperature PG and on age. You will not need to do any aging. So as you can tell, comparatively, it will be much easier. I'm showing here an example. There are two blends using a PG 5828 with wrap only. So a low percent of wrap, 0.3 RBR and 0.5 RBR. And these are their respective values here. The square is a 0.3. The circle is a 0.5. On the left axis, I have the virgin PG. On the y-axis, I have the wrap PG. So I'm just assuming a linear relationship there, linear correspondence. And this is sort of, if I were to make a blend with this wrap, I will get a 67.7 PG grade. So with that value, which is what I'm calling here the PG high of the blend, I can estimate the recycling agent dosage. How do I do that? Well, once I have that value, I can subtract the target PG. Remember in the previous example was a 70? And I can divide that by something that I'm calling slope rate. I don't have time to go into detailing here how we get this value, but if most of the recycling agents will tell you, okay, every percent dosage you add, you will reduce your PG by this much, like 1.7 degrees or 1.9 degrees. So we, based on our testing, we have estimated for a given number of recycling agents is about 1.7 degrees. So once you know your PG high of the blend using this previous method I showed, which will be these values here in the middle, and you know your target based on climate and traffic, you can estimate your recycling agent dosage. Now, it is a quick method. It will give you an initial estimate. It's not perfect for all recycling agents, but for the most part, it works well. And if you just want to know, like, okay, I need to know a ballpark estimate. Is this blend good enough? Am I putting too much wrap or too much RAS? You can get an idea without having to do the full-blown testing. Now, if once you decide, okay, it's reasonable, then you can do the detailed method and get a more, more accurate number. Previously, I mentioned blending. Even in this method that I show here, on this linear relationship, we're assuming 100% blending of the virgin and recycled materials. But in reality, we're not getting all the binder from the recycled materials out. It's not blending totally with the virgin materials. So how much is blending? If we assume everything like it's currently done on most mix designs, when you estimate the amount of binder on your wrap or your RAS, you count it all in. So you're assuming all of it is going to participate in the mix. But in reality, it's something in between that and getting none. So this will be the case where your wrap and your virgin don't mix at all. So it's a 0% blending. It's just like a black rock. So what factors affect blending? Aging, of course. So the level of aging in your recycled materials will affect your degree of blending. This is an example. We generated artificial wrap in the lab. So we aged mixture for different periods of time in the lab. So wrap 1 was less aged, and wrap 2 was more, wrap 3 was more, wrap 4 was very, very aged. And we just artificially did those materials and estimated the how much of that binder was blending in the virgin mix. So as you can see, with aging, the degree of blending goes down significantly. What about for real wrap? Okay, here we had a Texas wrap. We measured the high temperature PG. It was about 108. We had a wrap from New Hampshire with a high temperature PG of about 90. So just because of the difference in aging, we could tell there was a difference in the degree of blending, about 40% for the Texas, about 73% for the New Hampshire. So just how much aging you have in your recycled materials will determine how much of that binder comes in. Now, this was a sort of like an interesting experiment. We were adding the recycling agent directly to the wrap and then to the binder. So when we added to the binder, we saw like a marginal increase in the degree of blending, but when we added directly to the wrap, the increase on the degree of blending was much higher. So we also think these are important variables to look into, not only how aged are your materials, but how are you adding your recycled agent to the mixture. And just to give you sort of like a comparative idea of how Texas compares with other states, these are real wraps we have received from multiple states. We measured the high temperature PG, low temperature PG. So as you can tell, Texas has the highest of all. And we couldn't even grade it because the low temperature PG was minus 2.4, which means that if you try to round up to the grade, it would be positive. So that's just to give you a flavor of what type of materials you probably be dealing with. So these are just a summary, some of the takeaways. That there's a push to increase the amount of recycled materials in asphalt mixtures, but there's some issues with construction and performance issues. We think we can achieve that by using recycling agents in mixtures, and there may be a way of finding the right one, but it's still a work in progress. There's a way of estimating the recycling agent dosage with minimal testing, just to give a rough estimate. And also important is the blending between the recycled materials and the virgin materials. Partial blending occurs, and that degree of blending depends on the aging and how you add that recycling agent. So this is my summary of the presentation. I would like to ask you to discuss within your tables and give me what do you think is your takeaway from this presentation. So you will have about 3 minutes just to discuss among the people you're sitting with, and then you can use a poll everywhere to give me your opinion. So I will expect an answer, one answer per table. Yeah, fair. Okay, 1 more minute. Good answer so far. Okay, I think we got some answers. Thank you. I put here the contact information for the project director. She's sitting right here, Amy Epps Martin. Phone and email and mine. If you have further questions, I can get together with whoever asked about that 1.7. Where did that come from? I can talk to you after the session and go over that. I just didn't have time. But if you have questions, I can answer them now. You're asking about mixture test? We are doing some mixture performance tests as well on these blends. We're doing the semicircular bending test, SEB, and the BBR sliver, which is like sort of like a BBR test but with mixture. And we also, if we feel the recycling agent dosage goes too high, we also run the Hamburg to verify there's no rotting. Sorry, in the concept of the balance mix design.